Okay, I think we're ready to go with the live stream. Just want to check. The camera's a little fuzzy down that bottom right hand side. All right, let's get going. Check one more thing. So if there's any problems with the stream, let me know in the chat. I mean, it's going to be recorded as well, of course. So welcome. So this is part of the Fabric Data Days. So this is running all the way through November and December. There's a whole bunch of stuff going on. I guess it's almost like a festival of fabric. There's lots of certification stuff. So there's DP600 and DP700. So a lot of the official Microsoft events that are running, they're all running offers for the DP600 and 700 exam. This is not part of this. This is just, my own personal stream around fabric. But, if you're looking to take DP600 or you're looking to take the DP700, then there are those events, those official Microsoft events, as part of the Fabric Data Days. Now, I'm going to keep it to a normal conference session length, right? So we're going to be here for less than an hour, right? So 45 minutes to 55 minutes, something like that. Any questions, drop them in the chat. I want to try and keep this interactive. This isn't just a dry conference session of just delivering, stuff. We got some things to get through. When we get to the demo and we start looking at materialized lake views, drop some questions in the chat. If I can answer, I will. That's all we can ever do in this world. Now, materialized lake views. This is very much in the analytics engineering space. So this session is, can Microsoft Fabric Materialized Lake Views offer us easy analytics engineering? So the first thing, if you haven't dropped by the YouTube channel before, well, my name is Andy Cutler. So I'm an independent consultant working in the data space, predominantly Microsoft. But I've worked with Databricks and Snowflake, open source technology. So my consultancy is Data High BI. That QR code, it'll take you to Linktree. But my Linktree is, is Andy Cutler. All the links are in my YouTube channel anyway. And I blog at serverlesssql.com. And so you're at the YouTube channel now, which is Andy Cutler Data. Now, the agenda for today is analytics engineering. So we'll have a little look at what analytics engineering is. What are the options from vendors in terms of analytics engineering? We'll look at materialized lake views. And then we'll look at a framework that I've created because I'm lazy and I want things to work more automated. So we're going to have a little look at this framework that I've created that helps materialized lake views work a little better, I think, and kind of copy other approaches. Now, then analytics engineering. So I don't know if anyone is familiar, drop in the chat if you're familiar with analytics engineering. But this is not about taking data from source systems and deduping and cleansing that data. Analytics engineers, they're taking trusted, cleansed data sources. That's what they're doing. The data engineer is the person who's gathering all the data from all the different data sources. So that raw data, if you think of a typical data flow, left to right, raw data, that's the data engineer's role. To bring that raw data in, to do the heavy lifting, really. Cleansing the data, deduplicating the data, possibly enhancing with reference data and master data. On that right-hand side, we've got reporting. Now that could be ML, it could be AI as well, but I'm just wrapping up the business-facing part of the data flow with reporting. So in the middle, that's where analytics engineering is living, right? So we've got cleansed data, model data, and semantic model, right? So those analytics engineers, they're taking the cleansed data, they're modeling it in whatever modeling pattern suits the company, the environment, the organization, the project. I'm not going to say what kind of modeling is going on here, but it should be modeled. But they're also building, and of course I'm using Fabric/Power BI terminology here, so they'll be building a semantic model. Then possibly working with analysts to help understand the model, and possibly training the analysts in how to use the semantic model, and then the analysts can build reports. I will come to your question. I'm going to come to that in a minute. I'm just going to get through a couple of the analytics engineering slides, right? So ultimately, analytics engineers should know a data transformation language, SQL. It's not going away. SQL is not going away. Python, of course, becoming ubiquitous with data transformations. I mean, the number of libraries available for it is absolutely incredible. And of course, we've wrapped that into PySpark as well. But either or, you can do analytics engineering with SQL, you can do it with both, and you can do it with Python only. Except MLVs only support SQL at the moment. Spark SQL. Python's coming at some stage. But as the name suggests, engineering, yes, they're building and maintaining those data models. They're loading data with pipelines, with code, with logic. They're ensuring that these solutions are scalable and they're performant. But they have to work with the business users. They have to work with the data analysts. They have to work with the data engineers. It's no good just doing all of this in silo. You've got to understand the data that you're getting and crucially how to feedback requirements to the data engineers to make sure you get the data that you need. And of course, you've got to work with the business to understand what their data needs are. What do the analysts need to be able to deliver what they need to the organization? So let's touch on this. Recently, it's been announced that DBT will be available on Fabric. What are the decision criteria to choose between DBT and MLVs? What are the differences? Right, number one, huge differences. So yes, DBT is available on Fabric. I was lucky enough to be able to get my hands on it. Mostly because I said to Microsoft, please, can I be on the private preview for DBT? Massive amounts of difference. Huge, right? DBT, fully featured product. Been running for years, right? MLVs, they've only been out a little while, a few months. Not even that. Very immature. They don't do nearly as much as what DBT can do. And the differences, I mean, are vast, right? There's DBT does lots of things, and MLVs, they just do a few things at the moment. I don't know whether Microsoft will ever want to make MLVs like DBT. I suspect that what Microsoft will do is make MLVs compete with Databricks Lakeflow Spark declarative pipelines. They used to be called Delta Live Tables, but of course Databricks doesn't just support Delta now, so obviously Delta Live Tables doesn't fit with that technology anymore. So I think they'll kind of try and give it parity with Databricks, declarative pipelines rather than trying to make it DBT. So with DBT, I mean, I love DBT, right? It's fully featured. All sorts of options there in terms of managing slowly changing dimensions using snapshots. You've got, you can seed data. You can run incremental refreshes, specify all the different types of schema maintenance that you want when you change your transformations. So the decision point is how complex your project is going to be. MLVs, they're quite simplistic at the moment. They're really only going to fit a reasonably simplistic data flow. Speaking of which, here are our options. And working with Fabric and DBT, well, I mean, it wasn't really necessarily straightforward. You could use DBT Cloud, but of course that can be quite expensive as it scales. DBT Core, which is what I use, has a Fabric adapter. It's got the Spark adapter, but I really don't know what's going on with that Spark adapter. It doesn't really seem to be advancing. But with the warehouse service in Fabric, this is what I've been using DBT with. And of course, as new features have been added into the Fabric warehouse, like merge, like being able to, drop columns and all these things that we should have had at the beginning, those features have found their way into the DBT Fabric adapter. So it's starting to work very well together. As I've said before, Lakeflow declarative pipelines, although they've now added the word Spark, so it's Databricks Lakeflow Spark declarative pipelines, or it might be Databricks Spark. I don't know. They're swapping those words around willy-nilly. But ultimately, probably a simplified version of DBT. We're still declaring dependencies between loading processes. We're still not having to create tables with schemas. We're creating transformations, and the transformations itself are creating the schemas and creating the objects. SQL Mesh, I don't know if anyone has used SQL Mesh. I haven't. I'm adding it here because I see lots of discussions, DBT versus SQL Mesh. I'm not here to say which is better at all. I like DBT only because that's what I've used. And if I had some more hours in the day, then maybe I could explore SQL Mesh. But loads of people love SQL Mesh. Loads of people love DBT. And of course, what do they have in common? So it's declarative. This is the approach. It's if you're looking at frameworks. So I've built loads of loading frameworks over the years in which I use metadata to automate the schema creation of tables and alter tables and all that kind of thing, where these tools just do it for you. The adapters are what's working with whatever system that you're using. So if it's Databricks, if it's SQL Server, if it's Fabric Warehouse, then if the tool supports whatever data manipulation features are available in those platforms, that's what you can do. But it's building dependencies as well. So as well as not having to manage any of the schema or table creation or creating columns and maintaining data types and adding new columns and dropping columns and all that kind of business, that's doing it for you. But it's also to do with the dependency of the loading processes. So this is what all these tools have in common. MLV, DBT, Lakeflow pipelines, it's all creating a dependency between the loading objects so that certain tables that need to be loaded, certain objects that need to be loaded before other objects, they can be loaded first. It'll look to run things in parallel. So for example, if you use DBT Core or the cloud, you can specify, let's say, the number of threads that DBT will initiate and run on your platform, so as not to, let's say, flood it with too many requests. And whatever, I'm going to bring up different tools have different features and maturities. So some of the tools like DBT, they have testing and validation in it. So with DBT, you can set up tests. That's going to test data quality. It's going to test constraints, so on and so forth. Things like MLVs, very basic. We've only got constraints. We haven't got the ability to run tests and tell us when tests have failed. So when we look at MLVs, then it's going to look very similar. So we've got a dependency of objects, these materialized late views. Now, ultimately, these MLVs just are tables. It's a slightly different type of table with some additional metadata. And as the name suggests, the data is actually physically copied and materialized and is saved to the lakehouse. So this isn't a reference to data. This isn't a it's not data virtualization. It's not a shortcut. It's not a view into the data. It's loading and saving the data locally. So obviously one of the benefits of MLVs is if you're creating quite complex transformations, you can define that complex transformation. You don't have to define a schema or a table. You can run the computation of that complex object however many times you need to get the updated data. One thing to note is that unlike other similar features and tools, MLVs do not automatically refresh when source data changes. There is no auto detection to run a data load in an MLV when the data changes. You have to initiate a load through a SQL command, through the API, or scheduling it. It's usually you're going to do it through scheduling, because the whole thing with scheduling is the scheduling is going to work out what needs to load before other things need to load. Now, Medallion. So we obviously couldn't get through a Fabric session without talking about Medallion architecture. Very useful here. So these tools are taking data from one place, transforming them, and putting them somewhere else. Usually in some form of data platform loading process, whether we're going from bronze to silver to gold. And I'm going to use those terms. This isn't the time or place to dive into Medallion terminology and if it's right and if it's wrong and all that kind of stuff. It's just layers, right? It's just moving data from one layer to another. So, for example, if I've got source data and I'm bringing it into a lakehouse, then if I have a lakehouse in the same workspace, then I can use MLVs, right? I can select from source tables and I can insert into destination MLVs. If everything is in one lakehouse, absolutely no problem. If I have a lakehouse in another workspace, I can actually physically create the MLV. The problem is the lineage breaks. So there is no cross workspace support yet for MLVs, but cross lakehouse within a workspace, yes, this all works fine, and the lineage still works across the multiple lakehouses. You just can't do it across workspace. So something that's been added recently is an option called optimal refresh. So this is literally a button in the GUI. You switch it off, you switch it on. If you switch it off, regardless of whether the source data has changed or not, all the MLVs will refresh. They'll load their data again. So if you switch it off, this is like the brute force, right? It doesn't do any checking. It doesn't see whether it needs to load data or not. It's just going to do a full refresh. If you switch it on, then dependent on other settings will depend on the behavior. So there is a Delta feature called CDF, Change Data Feed. So this enables you to pull out a little bit like CDC. So if anyone's familiar with change data capture in, SQL Server or Azure SQL database, any other relational database that has, change data capture, this is the same thing, right? Change data feed just adds a little bit of metadata to the table and tracks changes over time so that you can go in, query, and only pull out the data that's changed. If you've switched that on a source table or an MLV, you can enable change data feed on an MLV as well. Then it does some further checks. So has the source data changed? If it hasn't, well, there's no point doing any form of refresh. If it has, it will do an incremental refresh, and the incremental refresh will be done based on the change data feed. So that's how it's able to do an increment. This is how MLVs are able to do incremental refresh. They're just using an existing feature called change data feed. If you don't have change data feed enabled, then again, if there's no change to the feed, if there's no change to the source data, you don't need to refresh anything. If there is a change, because you're not tracking changes over time, it has to do a full refresh of the source. Now I've tested, switching on optimal refresh. I've enabled change data feed on tables, and I get incremental refresh. Gen MLV, we'll just go through this really quickly before we jump into the demos itself. So what we'll see with MLVs is that I have to create materialized lake view statements. I have to do that in a notebook. I have to write these statements out. I have to run these statements. So I kind of have to manage creation of these MLVs within a notebook. I actually quite like the way, let's say, DBT does it, right? Where each transformation or each SQL file is responsible for creating one materialization. Now, in DBT, a materialization, it could be a table, or it could be a view, or it could be ephemeral. It only exists for the duration of the run. But it's one SQL file for one object. And I just use that as inspiration here, which we'll see. But what it means is that I can just write SQL statements that do the transformation, save them as SQL files, put them in a Lakehouse files section, run the Gen MLV process, and it will automatically create materialized lake views and synchronize the lake views. So we'll see that. Right, let's get into it. Let me bring up here. So first, I'll zoom in a bit. So firstly, anyone got any questions they want to drop in the chat before I carry on? There is a bit of a lag, so I'll just kind of wait to do that. Well, in my testing, yes, that has changed, Shelby, is that across Lakehouse, I can set up an MLV in one Lakehouse that loads data from another Lakehouse. As long as they're in the same workspace, works absolutely fine. I get lineage, it works absolutely fine. Maybe if we've got time at the end, we'll do a little test. Actually, let's just I'll just create a Lakehouse now, and then we can do a test at the end. I have to enable Lakehouse schemas. Mat views. I'll call this gold. Like I said, we're not here for naming conventions. Okay, so in my Lakehouse, I have a schema called bronze. Now, what I've done is I've just shortcutted to 4 tables, right? I've got dates, I've got event types, I've got products, and I've got web telemetry. So all this is just my own sample data that I use when I'm working with anything in Fabric. So it's essentially just a mock product website. People can go to this website, browse products, they can put products in their basket, and they can buy products. Kind of typical funnel analysis. I've just brought those in from another Lakehouse. They've just been shortcutted in. They're in the bronze. They're in the bronze layer. Now, yes, I'm talking about analytics engineering, loading data from cleansed and modeling it and all that kind of stuff. But I'm just extending the example, right? we're going to load data from bronze into cleansed, and then from cleansed into modeled, i.e. silver and gold, just to show you the range of dependencies that an MLV can represent. Right, let's jump into the notebook. So we'll create MLVs. Okay. Right, let's just start up the starter pool. Should be a few seconds. Just look at the chat every so often. All right. So we'll get some data back. Now, the object of this is not to show you lots and lots and lots and lots of complicated SQL. Right? That's not the point of this session. It's just to show you how the MLVs work. Right? You want to write loads of complex SQL? That's up to you. I'm just using these statements as an example. All right. Now, schemas. Let's create schemas. I've got silver. I've got gold. We'll refresh that. We'll see that under the tables section. Now we've got the syntax. Create materialized lake view. If not exists, silver dot cleansed dates. Like I said, fairly simplistic. I can add comments, right? And I've got table properties as well. One of the things I haven't yet been able to test, because like I said, there's only so many hours in the day, is I mentioned enabling change data feed on tables and materialized lake views. It was actually on Reddit that someone raised this issue, and then I tested, and yes, I found it was an issue. If you enable change data feed on a materialized lake view, when the materialized lake view refreshes, and I don't mean dropping the view and recreating it, I just mean it just refreshes with latest data, the change data feed gets disabled. It just vanishes from the table. I was told by Microsoft to add it to the table properties. I haven't been able to test that yet, so it's just a word of warning. If you're testing any MLV stuff, and all of a sudden you don't see incremental on materialized lake views, even though you've enabled change data feed, it's dropping it after it's refreshed the data. So let's run the creation. So create materialized lake view if not exists. As a side note, we're not able to alter a materialized lake view and change its definition. We've got to drop it and recreate it. We can alter a materialized lake view and change its name, but we can't change its actual definition. You've got to drop it. You've got to recreate it. And we'll have some information, right? So we've got some metrics here, right? So that refresh policy, there is a system table that tracks what MLVs are doing when they're being refreshed, right? Is it a full refresh? Has no refresh happened, or has it been an incremental refresh? So we've actually got a table. If I have a look at DBO, there we go. Sys DQ metrics. Let's just extract the columns there. We'll have a look at that in a little while. But we've just got some metadata around what happens when MLVs are refreshed. Naturally, that view feeds into an automated Power BI report that you can create as part of the MLV process, which I think works now. It didn't work. It didn't work a while ago, but I think it works now. So if we open Silver and refresh, then we've got this cleanse dates, right? And we get a little, and I don't have oops. I don't have zoom it enabled, but cleanse date's there. You can see the little lightning bolt, the little icon that denotes this is an MLV. But essentially, we would query that as if it was a table. Now I'm just going to bypass the drop materialized lake view statement. And let's run show materialized lake views, because what we can do is we can use some metadata and get a list of the materialized lake views that's in a specific schema in our lake house. We can see the definition of the MLV. Right, so we've got, we get returned the create materialized lake view statement itself in terms of being able to access it, or certainly access the creation statement of that MLV. So I'm going to alter the MLV and change its name. Like I said, you can't change the definition using an alter. You've got to drop it. You've got to recreate it. Let's refresh that. There we go. Cleanse date's new. That's the new table. Now I'm going to create another materialized lake view, which is actually going to pull from the silver materialized lake view. So let's run that, because ultimately you can chain these together, right? Now it's up to you to maintain, and this, I guess this is going to be another functional difference between DBT and MLVs, is that with DBT, you use references within your SQL transformations, and those references reference other transformations or other models, other SQL files. That's what gives DBT its ability to build that DAG, that dependency of what needs to run before other things need to run, because it can see what's referenced by what. Here, this is all behind the scenes in terms of from, right? So MLVs will track where it's getting its data from, but the problem is it's not doing that, and you can't do it through auto creation. And what I mean by that is you're defining your create materialized lake view statements. You're responsible for putting them in the order in which they need to be created. Now that's fine. Once you've created those MLVs, the refresh is then taking care of the dependencies of when it needs to load. But you're having to take care of how you create those MLVs. Tools like DBT, when it compiles and runs the project, it does it itself. It works out the dependencies, not just from a loading process perspective, but also what objects need to be created in what order. Yeah, we don't have that luxury here in MLVs. So let's have a look at gold, and we'll just refresh that. Yeah, there we go. And we've got dim dates. So at this point, let's have a look at what it looks like in the materialized Lakeview interface. I get that from the Lakehouse view, not the SQL Analytics endpoint. We're going to manage materialized lake views. Pretty simplistic, right? Because all we've done is we've just created one MLV that points to another, points to a source table, and then we've created another materialized lake view that points to another MLV. So here is where we can schedule, right? So let me just set schedule on. And yes, I've fed that back to Microsoft. That still seems to be an issue in terms of the language. No, I'm not. Is that's Portuguese, I think. I'm definitely not in Portugal. But I can schedule a refresh. I'll set it to run every 5 minutes. Let's just set it for now. There we go. Set it for 8:30. We'll set an end time for later on. There we go. All right, apply. Okay, now, because I've got that optimal refresh on, we're not going to see any refresh actually taking place. And actually, what I'll do is let me set that schedule a little bit more aggressively. Now, I thought, well, okay, I'm responsible for creating these MLVs. I've got to define my select statement anyway. I've got to have a create materialized lake view. I've got to manage the process of these MLVs. So I just thought, well, actually, I do quite like DBT. I like how DBT is put together with discrete transformations, right? So I can have a transformation which ultimately gets materialized as an object, a table, or a view, and I can just manage my transformations just in these individual files, which I like. So with MLVs, I've done something similar. Right? And as I said, it's probably just because I'm lazy. I don't really want to have to manage the creation of the materialized lake views in a notebook. So I've got a GitHub on data. I mean, I'll just drop that in the chat if anyone wants to go and check that out. But essentially, it's very simple. It really is very simple. It's a single. Let me just go back to the. Okay, my browser's just stopped for a minute. There we go. I think I froze for a second. Yes, so it's a PySpark, right? So it's just a series of functions. It's all in one script. Like I said, very simplistic at this stage. I haven't bothered modularizing it yet in terms of, different files. But what this does is this enables me to, if I'm going to go into the files section of this lake house, right, actually, let me go to the lake house and we'll have a look at the files section. So I've got a folder called MLV. Under that, I've got a series of numbered folders. Like I said, MLVs currently don't have any dependency tracking when creating the MLVs. That's your responsibility. So essentially, what I've done is I've got 4 folders, and it is the dependency of the creation of the objects that I've put in here. This isn't about refreshing, it's just the creation of the objects. So if I go into O1, then we can see I've got 4 SQL files. So if anyone is familiar with DBT, you'll get where I'm coming from with this. But ultimately, I can go into this file and write my select statement. I'm not writing the create materialized lake view statement. That's all been done for me by that PySpark script. I need to write everything from the constraint onwards. Now, obviously, I don't need to have constraints. I don't need to have comments. I don't need to have table properties. In fact, it could just be like that, right? But I've got constraints. Now, what constraints do is if the constraint fails, then you can decide what to do. You can decide whether you just want to drop the row, but that gets reported on. So in those metrics in that system table, you'll see that rows have been dropped. You'll also see it in the data quality report as well. So I prefer this rather than putting filters in the load, because the filters, I guess they're kind of hiding the problem. Whereas if you put the check constraints in the MLV itself, you can at least see numbers of rows that are failing and you can go back and check, right? So you can actually either drop the row and the MLV will carry on processing, or if you want to fail the MLV, if a constraint is violated, then you could do that as well with the on mismatch fail. That will be. But look, as you can see, is I've just got a series of SQL files. Yeah. So again, anyone familiar with DBT, this is kind of what I'm doing. Right. So I've got my silver. Right now, all of these can be run. They're not dependent on each other, right? So you can run any of those four in sequence, in parallel. Doesn't really matter. And then from there, I've got my gold, right? So I'm loading into a date dimension, an event type dimension, and a products dimension. Then I've got a fact table, right? And that fact table, it uses the dimension tables when it's loading into it. So as you can see, yes, this is a dimensional model. This is a star schema. And lastly, I've got some aggregates, right? I've got some pre-computed aggregates where I'm summarizing and grouping data from that fact table by the dimension tables. So this is my process. Right? So I've essentially created a loading process using these SQL files, but it's also going to be materialized. It's the tables, it's materialized lake views. This is this whole process. So from here, let me open up the notebook. So Gen MLV. Right, so I'm going to drop the two tables that we created earlier. We don't need those anymore. So we've got nothing in gold, we've got nothing in silver. Now what the process does is it's iterating through those folders. So I'm actually going to set it to a dry run true. So it's iterating through those folders, seeing the files, reading the names of the files, and I should point out at this stage, so let me go back to the tables, is that the naming convention of the table, the naming convention of the file is the schema.mlv name. So the process will automatically check for the existence of the silver schema. If it doesn't exist, it will create the schema. Then it's going to create the MLV. But what this process also does, and we'll check that in a minute after we've run it. There we go. So we've got a flag to say dry run. So it says it's going to create the 4 silver MLVs, the 3 dimensions, the fact table, and the 2 aggregate tables. So let's set that to true. And what it's doing is it's just reading those folders, reading the file names, using the file names to create the schema if it doesn't exist, and to create the materialized lake view. Then it's pulling out the SQL statements within each file and using that as the definition for the MLV. So let's see if it's starting to create these MLVs. There we go. So it's just looping through and creating these MLVs. Like I said, I'm lazy, right? So I don't want to have to go into a notebook and create materialized lake view and drop a view and change the definition and have to recreate the MLV. So what this framework does is if you remove a file and then rerun the code, it checks, it sees that there is no longer a definition in there. It checks its metadata and says, well, you have an existing MLV, but you no longer have the file. It removes the MLV. If you go in and change the definition of the MLV and save it, and then run the process, because the files have got, because the files have got a date modified on them, the process can see that a file has been modified. It'll then drop and recreate the MLV. So you can go in, essentially change the definition of an MLV, run the process. Process is going to automatically synchronize your MLV file list with the MLVs in the lakehouse. So there we go. So let's just have a look at that. Let's just refresh that. There we go. We've got our 4 cleanse tables. We've got our 3-dimension tables. And we should have very soon those aggregate tables as well. So let's just keep refreshing while it's computing. I don't know if there's any further questions in the chat. So while that's running, actually, what we'll do is we will I'm just going to drop in the chat the actual official documentation. There's nothing quite like the official documentation because I do sometimes miss that. There we go. Right. So if we refresh on gold, then we can see we've got the tables created. Right. Let's have a look at the dependency in the Materialized Lakeview UI. Let's look at bronze. Let's just make sure that they're appearing in the lake house. Yeah, there we go. Gold and silver. Okay, Materialized Lakeviews. There we go. Right, so we had our simplistic MLV that we created. Let's refresh the lineage. Let's fit. We might have to scale in a little bit. You can switch the view, right? So the Microsoft documentation has the MLVs going from top to bottom. I can't really work that out in my head, right? A data flow for me is always left to right. It's not right, it's not wrong, it's just how I do it. But yes, so here we go. Here is the MLVs. So if we pull out those aggregate tables, and then, oops, sorry, I realise I'm sort of zooming in and out a little bit willy-nilly. But here's the DAG. Here is the dependency. This is what MLVs are doing behind the scenes when you're creating them, right? So I can look at raw products and say, well, where does raw products go? Well, it goes into Silver Cleanse products. It goes into the DIM product dimension. It's used in fact web telemetry. It's used in the gold aggregate web telemetry query. It's used in both the queries. I can look at dates and I can see where that is being fed into. Right, so we can look and check at the dependencies of each of these MLVs and see the downstream and see the upstream. Then we've got this optimal refresh, right? So what I will do is I'm going to schedule this every, it's already scheduled as part of it. So what I would say is that when you're creating MLVs in a warehouse, when you're creating MLVs in a lake house, the schedule affects all of the MLVs in that lake house. You can't selectively pick which MLVs are in a schedule. I would have liked that. Maybe they'll add it. Probably should create an idea for that. Right. So when you hit schedule and you create a schedule, that's going to affect all of these MLVs. Right. So if data changes, it's going to refresh the data through the MLVs. So the last thing we'll look at is the system table that gets created. So let's have a look. We'll look at the create MLVs. Now we get this table created. Let me just go to the top. sysdq metrics. Well, actually, let's switch to the SQL endpoints. There we go. We're already in the SQL endpoint in this tab. Have a look at tables. sysdq metrics. So select top 10. Okay, so we'll order by the refresh date descending. And then from here, well, we've got our metadata, right? So we can see all our, the namespace, which is the lake house, the MLV name, the refresh policy. Now, the naming convention for me on refresh policy, not as clear as it could be, but it's the refresh policy basically tells you what happened to that MLV when the schedule ran or when you ran a refresh command. Right, so we can see that, well, there was no refresh for dim date. Refresh time, sorry, refresh. Let me go back and say refresh timestamp, and we'll rerun that. Okay, so let's scroll down. Right, there we go. Now, the first time that we ran the MLV process, i.e. when GenMLV created the materialized lake views, it did a full refresh. So we can see full refresh, and we can see all the rows that refresh loaded. We can also see the violation. There we go. So products. So I've got a constraint in a product. So let's have a look at that. We'll very, very quickly have a look at that product. Product. Yeah, so I've got a constraint to say, look, if the product color is not null, right? So basically, if it fails that, then drop the row. Don't load the row in, right? Now I could go back and check the check my products. So it's not hiding. It's actually telling me that during that refresh, let's scroll down, that it dropped 50 of the rows due to violations. The violation was on that constraint, right? So we can go back, check the source data. So at least we know how many rows got dropped. We can't see the rows themselves. We just know they got dropped. Now, I'm going to ask Microsoft about this to see if this is put into some table that we can get at, because that would be useful, even if it was just a key to the table, right? But at the moment, we can see like the total rows dropped. But then we can see on subsequent refreshes, and this is the schedule kicking in, that there's no refresh, right? The data hasn't changed. Now, if I was to go change data in one of those tables, then next time it refreshes, it's going to refresh the MLVs for that particular dependency. Now, my compute session was disconnected. So, like I said, the last update that we had to MLVs was the incremental refresh, which is very useful, right? But you've got to use the change data feed on the table to be able to, or the MLV to be able to take advantage of incremental refresh. If you don't enable that, if it does detect that data has changed, it's going to have to rerun the whole load. So it will be like switching off optimal refresh, right? So it's just something to consider as you're working through this. But that, in a nutshell, is the current functionality for materialized lake views. Now, I am keeping a very, very keen and close eye on this functionality because, look, this is just the starting point, and it will start to build up functionality, as we go. Now, I'm not saying Microsoft are just going to take other vendors and just literally implement the features from those other vendors. No, right? But there's going to be some natural features that get added to this in terms of streaming data, in terms of more nuanced scheduling, perhaps some automated computation when source data changes. I don't know. I'm not privy to the roadmap in terms of the internal features. But I like this process. I think that, certainly from, and I think someone dropped a question in a session that I did a few weeks ago on materialized lake views, which was, well, how many layers do you think we can compute with MLVs. I mean, I would say, look, I've it's not necessarily an extreme example, but we've got 4 layers here, right? We've got, let's bring that fact table into this layer, right? We've got the bronze raw layer, we've got the silver cleansed layer, we've got the gold layer, and we've got some aggregate layer. Now, some people may call this the platinum layer. I'm not going to go to the ins and outs of terminology, but as you can see, you know, we've got 4 layers here. Depending on the complexity of the project, using MLVs may not be the right thing to do if there is a lot of complex loading processes. Where I can see this really shining is where you've got, let's say, a whole bunch of silver tables, or you've possibly got a whole bunch of model tables as well. Like I said, it doesn't have to be a dimensional model, it can be anything. But you need some further computation on that to turn them into domain-specific data sets where it doesn't make sense to use a semantic model to do that. Right? So if you need to do some further transformations and people familiar with SQL can come along and do those transformations, I kind of see this being quite useful. Of course, with Fabric, what we would all love to see when any of these features get released is cross workspace. I get why it's difficult because of just the architecture of Fabric. Each workspace is almost like its own compute resource. It's almost like its own server. Therefore, cross workspace connectivity can, I think, for these features in lake houses and in warehouses can be quite, I guess, quite tricky to implement. I hope that's not the case, because I really would like to see this. Because if you can imagine, you've got a lake house in one workspace that's collecting all of your raw data, all your cleansed data, and maybe even your modeled. And then you use MLVs to start enriching lake houses in other workspaces as well. This is where I can see it being really, really powerful. So with that, I think we're pretty much bang on time for 9 o'clock. I might do another stream in which it's less structured and we just play around. One of the things that I want to play around with is using materialized lake views in semantic models. What happens when what happens when MLVs get dropped and recreated? How is that affecting our semantic models, whether it's in import, direct lake, things like that. Diving into the optimal refresh, looking at the conditions in which incremental refresh will trigger. I'd like to look at that as well. Probably, the other side of December now, probably sometime in the new year. But anyway, thank you very much for joining me. I very much appreciate it. I hope that this has been helpful. Also, this is part of the Fabric Data Days festival. So if you've not seen other events that are happening from Microsoft themselves, you can get access to DP600 and 700 training material, support. I think there are vouchers for free certifications on that as well. So definitely look at that as well if you're looking to take any of the analytics engineering or the data engineering with Fabric as well. So look out for those. Lots of great people doing lots of free training and learning on that as well. So with that, I am going to say, well, it's 9 p.m. where I am. I don't know what time it is wherever you are in the world. If you're finishing your day, have a good night. If you're just starting your day, have a great day. And I will see you all soon. Bye-bye.